Mr. Clelland here for Clelland Maths. Today's the day, National 5 Maths Prelim Revision Special. You can see I'm getting my Christmas decorations up. This time of year, every single year, we've got our Prelim Revision Specials come in. Remember, I've got our app.clellandmaths.com. You can get our merch anytime you want, just check the links. But today, download this Prelim Revision Special PDF. The link is in the description below, and then watch this video and go through it question by question by question. Make sure that you do not use every single question. If you've not come up with a topic, just skip it. But hopefully this is useful to you, and I'm hopefully going to get it on the app later on. But for now, take the PDF, take the video, and hopefully have a great time with it. Don't get cooked, get Clelland, and have a Merry Christmas for when it comes. SQA National 5 Maths 2025, Paper 1, Question 1. 2 and 4 fifths times 2 sevenths. So I'll do 2 5s is 10, 10 plus 4 is 14, so 14 over 5 times 2 sevenths. Simplify now, 2 and 1, 2 2s is 4, 1 5s is 5, and we're done there. Off to all 40 marks it says, so question 1. Evaluate 3.5 minus 1 1/4. Two ways to do this. You could take away the numbers and the fractions, but I'm just going to do it the way most people would do it, which is to make a fraction. So I'll do 3 3s is 9, 10, 11, so that's 11 thirds. 1 4s is 4 plus 1 is 5, so minus 5 quarters. So then we can just make a common denominator. 3 4s is 12. 11 times 4 is 44. And 3 times 5 is 15. So I've got 15, 44 minus 15. 15, 25, 35, 45 is 29 over 12. Check if it's simplifiable. It isn't because 29 is a prime number. But if you're not sure, change it back. 12, 24 is 2. 25, 26, 28, 29, that's 5 12s. 2 and 5 12s. I'll do it the other way just to be on the safe side. 3 minus 1 is 2. 2 thirds minus 1/4. Common denominator equals 12. 2 4s is 8. 1 3s is 3. 8 minus 3 is 5 12s, so I get 2 and 5 12s. Exactly the same answer, so we're done there. SQA National 5 Maths 2025, Paper 2, Question 1. The number of visitors in a zoo in 2024 was 118,750. The number of visitors is expected to increase by 4% per year over the next 2 years. What's the number of visitors in 2026? So we just do 118,750 times 1.04 to the power of 2. So in my calculator, 118,750 times 1.04 squared is 128,440. And we're done. SQA National 5 Maths 2025, Paper 1, Question 4. In a sale, wedding dress reduced by 20%. The sale price is $720. Calculate the price before the sale. So I can say 20% off. 80% is equal to 720, and since 8 goes into 72, I can divide by 8 to get 10%. And divide this by 8. 8 9s is 72, so that's 90. And then go up to 100% by times them by 10. Times them by 10. Pound sign, £900, and we're done there. SQA National 5 Maths 2025, Paper 2, Question 3. The mass of 1 atom of gold is 3.27 times 10 to the minus 22 grams. The mass of 1 atom of carbon is 6.1% of the mass of an atom of gold. So we know the mass of an atom of gold. We have to look at the mass of an atom of carbon. So it's just 6.1% of 3.27 times 10 to the minus 22. So in a calculator to do that, I just do 6.1 divided by 100. Times 3.27 to the power of minus 22. And it gives me an answer of 1.9947 times 10 to the minus 23 grams. Now I could maybe round that if I want to about 2 or 1.99, but unrounding it doesn't make a difference because you're not getting asked to round. So we're done there. Expand and simplify. So we've got root 10 times root 10. Well, that's just 10. We've got root 10 times root 2. Well, that's going to be root 20. 2 10s are 20. And we've still got plus 8 root 5. So at this point, we need to check if root 20 can be simplified as a surd. We're looking for two numbers that go into 20. One's a square number. Hopefully it'll be 5. Let's just check. Root 20 equals root root. Well, 4 is a square number times 5, so that gives me 2 for square root and 4, root 5. So I can rewrite my problem as 10 minus 2 root 5 plus 8 root 5, which equals 10. 8 minus 2 is 6, so plus 6 root 5. And we're done. Can't add the 10 and the 6 root 5 because they're, well, different from each other. One's a whole number, one's got a root in it. Okay, 2018 paper 1 question 11. Express 9 over root 6 with a rational denominator. So we start with 9 over root 6. We times by root 6 over root 6. So this gives me 9 root 6 on the top over just 6 on the bottom. And I can simplify the number parts by dividing by 3. 3 goes into 9 3 times. 3 goes into 6 twice, leaving 3 root 6 on the top and 2 on the bottom for our final answer. SQA National 5 Maths 2025 paper 1 question 10. Simplify n7 times n3 squared over n4. So I'll do the n3 squared first. That's a power, so I'll do 3 2s is 6 over n4. Now I can add the powers 7, 8, 9, 10, 11, 12, 13 over 4. Then take away the powers, so I get 9. And we're done there. SQA National 5 Maths 2025, paper 1 question 2. Expand and simplify. So I always use grids for this. So I'm not going to change that now. X plus 3, x plus 5, plus 4, x minus 2. So that's x squared plus 3x plus 5x plus 15, 4x, and that's a plus, and then 4 times minus 2 is minus 8. So I've got x squared, and then 5, 6, 7, 8, 9, 10, 11, 12 x's. And then the number parts, 15 take away 8 is 7, so it's plus 7. And we're done there. SQA National 5 Maths 2016, paper 2, question 4 on factorising. Factorise through with 3x squared minus 48. Well, first thing we check if there's a common factor. Well, there is. 3 is a common factor, so I can divide by 3 to get x squared. And 3 into 48, well, 3 into 4 goes 1, with 1 left over. 3 6s are 18. So we get 3 bracket x squared minus 16. But that's a difference of 2 squares. So how do you factorise that? You know it's a difference of 2 squares because you've got an x squared or something squared, and then take away a number, which is a square number. So that's just double brackets. X in each place, square root of 16 is 4, so that goes in each place, plus in one bracket, minus in the other, and you're done there. Solving quadratic equations by factorising. SQA National 5 Maths 2018, paper 1, question 5. Solve x squared minus 11x plus 24 equals 0. So you should recognise that's a quadratic or trinomial because it's got an x squared, an x, and a number. So since it's paper 1, I know we're factorising most of the time because if we use the quadratic form, we're going to get decimals. So unless it tells us to in paper 1, factorises. Looking for a common factor, there's no common factor, so straight away it is double brackets. And this is quite a simple one. If it's just an x squared, I can write x and x straight away. To get my other numbers, I'm looking for two numbers at times to make 24, but add to make minus 11. So at the side, what you could do is write minus 11 and 24. Writing down all the factor pairs of 24, so 1 times 24, 2 times 12, 3 times 8, 4 times 6, and then I'm done. And you're looking for those pairs, can I add or take away to make minus 11? Well, I clearly can't do that with 24 and 1. I can do it with 12 and 2. No, can't do it. Can I do it with 3 and 8? Well, 3 plus 8 is 11, so yes, I'm going to be able to do it. And can I do it with 4 and 6? Nope. So how do I do it with 3 and 8 to make minus 11? Well, I need minus 3 and minus 8 to make minus 11. And just double check at the end. Minus 3 times minus 8 is 24. So I've done it right. Minus 3 minus 8. So we've got two brackets that equal 0. That means that x minus 3 equals 0 or x minus 8 equals 0. And just solving those equations, x must be 3 because 3 take away 3 is 0. Or x must be 8 because 8 take away 8 is 0. And we're done there. Maths 2024, paper 2, question 6. Factorise y squared minus 6y. Common factor is y. Bracket y minus 6. Done. Hence simplify this. So I already know the top is y minus 6. So I need to factorise my bottom. So I check for a common factor, y squared minus 3y minus 18. No common factor, so it's double brackets. Now, you should be able to surmise or guess that you're going to get y minus 6 in one of them. But let's just check. You get y and y, and if you're not sure, you're looking for two numbers that times the 18 but add to 3. Just then we've got a note with minuses. So 1 and 18 doesn't make 3. 2 and 9 don't add or take away to make 3. 3 and 6, well, they do add or take away to make 3. So I want minus 3. So it's minus 6 plus 3 is minus 3. So in one bracket, I get minus 6. In the other bracket, I get plus 3. And now we can just simplify by same brackets, they disappear to get y over y plus 3. Do not be tempted to then simplify the y's because the plus in the way, you can't do that. You're finished there, and that's us done. Question 12. Express that as a single fraction in its simplest form, algebraic fractions. X plus 2, x plus 2 squared. So x plus 2, and it's a divide. So the first thing we're going to do is get rid of that divide. So we've got 4 over x plus 2. Divide means we change to our times, and we flip the second one upside down. And now we can simplify and advance as normal. So we've got x plus 2 and x plus 2 on top and bottom, so I can take one of them away, and that just leaves x plus 2. And then we can answer the question. You've got 4 times x plus 2 over 5. And we're done. No need to expand the bracket because it's already simplified. It doesn't make it any simpler. SQA National Maths 2025, Paper 1, Question 14. Express that in a fraction in its simplest form. So I can just times them together, making sure we've got x minus 1 in brackets. X minus 1. 5 times x is 5x. We are minus 4x minus 1. Expand and simplify our top then. 5x minus 4x. Watch out. Plus 1. Plus 4. 4 times 1 is 4. But it's a minus times a minus. And then you need to just say, well, that's x plus 4 over x minus 1. And we're done there. SQA National 5 Maths 2025, Paper 1, Question 7. A function is defined as 3x plus 7. F of x is 3x plus 7. Find f of 6. So that's subbing 3 times 6 plus 7. That's 18 plus 7, which is 25. Part B, f of p equals 19. Find p. F of p equals 19. So p becomes x. 3p plus 7 equals 19. I can take away 7 then from each side to give 12. And then divide by 3 to give 4. So p is 4, and we're done there. SQA National 5 Maths 2025, Paper 1, Question 6. The diagram shows a straight line passing through points A and B. Find the equation of a line in its simplest form. So gradient is y2 minus y1, x2 minus x1, x1 y1, x2 y2. So my gradient is 2 minus 12 over 6 minus 1. 2 minus 12 is minus 10 over 5. That's minus 2. You'd expect a negative gradient because it's sloping down the way. Now I'll pick a point to be A and B. So I'll just pick 6 and 2 because they're easier numbers. Y minus 2 equals minus 2x minus 6. Expand. Minus 2x, a minus times a minus is a plus. And move the minus 2, minus 2x plus 14. And we're done there. That's the 5 Maths 2014, Paper 1, Question 11 says, a straight line has the equation 4x plus 3y equals 12. Find the gradient of the line. Well, that's quite easy then. So we just rearrange it to make y the subject. So we've got 4x plus 3y equals 12. So taking the 4x over to the other side, we get minus 4x plus 12. Dividing through by 3, we get minus 4 over 3x. Plus 12 divided by 3 is 4. And then stating our gradient, m must equal minus 4 thirds. And we're done there. Part B says find the coordinates of a point where the line crosses the Part B says find the coordinates where a point crosses the x-axis. So we've got 4x plus 3y equals 12, remember. Cuts the x-axis when y is 0. So we've got 4x plus 3 times 0 equals 12. So 4x equals 12. So x is 12 divided by 4, which is 3. So the point is 3, 0, x and y. SQA National 5 Maths 2024, Paper 1, Question 9. In a car rally, competitors start at different times. Scatter graph shows the ratio between length of time they have been driving in t minutes and the distance in kilometres to the finishing line. A line of best fit is drawn. Point A represents 3 minutes and 26. So that's 3:26. I'll take a note of that. Point B represents 10 minutes and 12 kilometres. 10 minutes and 12 kilometres. Find the equation of a line of best fit in terms of D and T. Okay, so it's an equation of a line. So I need the gradient, which is y2 minus y1, x2 minus x1. So I'll just call the first point x1 and y1, and the second point x2 and y2, or the other way around. So I've got 12 minus 26, just watch out for minuses, over 10 minus 3. And I'm expecting a negative answer because it's sloping down the way. So 12 minus 26, 12, 22, 23, 4, 5, 6 is 14. So I've got minus 14 all over 3. 10 minus 3 is 7. That is minus 2. And now the equation I use is always y minus b equals mx minus a. You might have been taught to use y equals mx plus c, but you'll get the same answer. So I'll pick one of the points to be a and b. It doesn't matter which, so I'll just pick the 10 and the 12. Y minus 12 equals minus 2x minus 10. Y minus 12 equals minus 2x, and a minus times a minus is a plus. Watch out, plus 20. So y equals minus 2x, 20 minus 12, so I'll add 12 is 32 plus 32. And I've usually done there, except the axes is not x and y, is d and t. So y becomes d equals minus 2. Is that a big T? Yeah, it is. T plus 32, and that's my final answer, and we're done there. Another competitor has been driving for 7 minutes. Use your equation to estimate the distance the competitor is from the finishing line. So I've got D, remember, is minus 2t plus 32, and they're telling me that t equals 7. So that means that D equals minus 2 times 7 plus 32. That's minus 14 plus 32. So I need to do 32 minus 14. So 24, 25, 26, 28, 29, 30, 31, 32, 18. 18 kilometres. Get your units in there. That is kilometres, isn't it? SQA National 5 Maths 2025, Paper 2, Question 13. Solve this equation. So, I've got 2 and 3 in the denominator position. So I think I'm going to times by 6 on both sides, because 2 times 3 is 6. There's other ways to do this, but that's my preferred method. So I get 6 5x plus 1 over 2 equals 6 fours is 24x plus 6. Simplifying this as I go, 6 divided by 2 is 3, 5x plus 1. 24 divided by 3 is 8, x plus 6. Expand the bracket. 15x plus 3, 8x plus 6. Move the x's to the left to start with, so that gives me 7x by taking away, plus 3 equals 6. Now move the 3, so I'll take away 3, 7x equals 3, divide by the number in front of x, 3 over 7, and we're done there. That's 2024 Paper 2, Question 4. Solve algebraic with an equation. So I've got 5x minus 2 plus 4 is less than 7x plus 8. So expand the bracket. I'm not going to use a box for this one. 5x, 5 2s are minus 10 plus 4 still, less than 7x plus 8. Collect like terms, 5x minus 10 plus 4 is minus 6, is less than 7x plus 8. Now I like to keep my x's positive, so I'm going to move the 5x to give 2x on this side plus 8, is less than, minus 6 is less than that. Move the 8, so it's minus 8. Minus 6 minus 8 is minus 14 is less than 2x. And divide by 2, minus 7 is less than x. I have solved it. You'd probably find like that, but to write it the right way, just flip the sign. X is greater than minus 7. Now, you would have also had to flip the sign if you had done your x's on this side, because you would have ended up with a negative x, and when you divide by a negative, you flip the sign. SQA National 5 Maths 2024 Paper 1, Question 7. Solve algebraic with a system of equations. So it's simultaneous equations with equations given. I always get rid of the second one, so that's what I'm going to do. But if you got rid of the first one, you should get the same answer. So you times this one by 2 to make 14r, and times this one by 7 to make 14r. 2 2s is 4p, 2 7s is 14r, and 2 11s is 22. And then the bottom one, 7 3s is 21p, 7 2s is 14, that's an r by the way, 14r, and 7 4s is 28. So now, if the signs are the same on the one you're getting rid of, you add. If they're different, you take away. So I need to add these together. 21 plus 4 is 25p, and that equals 28 and 22, which is 38, 48, 49, 50. And therefore, p is 50 divided by 25, so p equals 2. And now you just sub into any equation you want. I usually just pick the first one. So picking the first one, we've got 2p, 2 times 2, minus 7r equals 11. So that's 4 minus 7r equals 11. 11 minus 4 then, taking away 4 for both sides. 11, 10, 9, 8, 7. You get minus 7r equals 7. So r is minus 1. No other statement to make for this question, so we're done there. SQA National 5 Maths 2025, Paper 2, Question 10. On Bob's lorries are 7 stacks of paving slabs and 3 stacks of edging blocks. The total weight is 2,400 kilograms. Let P be the weight of a stack of paving and E is the weight of a stack of edging. Write down an equation for P and E. Well, that's easy enough. 7P plus 3E equals 2,400. Part B. Imran has 3 stacks of paving slabs and 4 edging blocks. The weight is 1,300. 3 paving, 4 edging equals 1,300. That'll be different for part C. Beth has 6 stacks and 5 of paving and 5 stacks of edging. What's the total weight of her stacks? Well, if I work out the total weight of a P and an E, I can just sub into whatever her equation would be. So that's my goal for part C. So I've got 7P plus 3E is 2,400. I've got 3P plus 4E is 1,300. So I can times this one by 4 and that one by 3 to get 12 in the second position. 4 7s is 28p, 4 3s is 12e, and 4 times 2,400 is 9,600. But you can use a calculator if you want. 3 3s is 9p, 3 4s is 12e, 3 nothings is nothing, 3 3s is 9, 3 1s is 3. Take away. 28 minus 9, so that's 19, I think. But if you're never sure, calculator's always worth. Yep, 19p equals, now I can't be bothered, 9,600 minus 3,900, 5,700. So p is 5,700 over 19, which is 300. And now I need to work out my E, so I'll sub into an equation. So I'm just going to pick this one. 3 times P, which is 300, plus 4 times E equals 1,300. So 900 plus 4E equals 1,300. So I take away 900, well that gives me 400. And I divide by 4, so that gives me 100. Now I always like to answer it just to be on the safe side. So the weight of a paving slab is equal to 300 kilograms, and the weight of an edging slab equals 100 kilograms. But I've not actually answered the question yet. If you've stopped there, you've missed something, because it does say calculate the total weight of stacks of paving slabs and edging blocks on Beth's lorry. Let's just make sure Beth's only got one lorry. Beth's got a lorry, Imran had his own lorry, and Bob had a lorry. So it's just Beth's lorry. So it's 6p and 5e. So for Beth, we can say her total weight is given by 6p plus 5e. So that is 6 times 300. plus 5 times 100. That's 1800 plus 500. That is 18, 19, 20, 21, 22, 23, 2,300 kilograms. And we're done there. SQA National 5 Maths 2025, paper 2, question 9. Change the subject of the formula to k. So where's my k? It's right here. So I need to add 3c first. b plus 3c equals a quarter k c squared. Now I want to get rid of that quarter, so I'll times both sides by 4. So 4 bracket b plus 3c, or 4b plus 12c, equals kc squared. Now, I need to divide by c squared to get the k on its own. 4b plus 3c all over c squared. Or in other words, k equals 4b plus 3c all over c squared. And we're done there. SQA National 5 Maths 2016, paper 2, question 9. Express x squared plus 8x minus 7 in the form x plus a squared plus b. So this is called completing the square. So how does this work? Well, we half the middle term. So it's x plus 4 all squared. We immediately take away this number squared, which is 4. So it's 4 squared. And then we've still got minus 7 on the end. So that gives me x plus 7, 4 squared, minus 16 minus 7. X plus 4 all squared, minus 16 minus 7 is minus 23. And we're done there. SQA National 5 Maths 2018, paper 1, question 16. Sketch a graph of y equals x minus 6, x plus 4. On the sketch, show the points of intersection with the x and y axis and the turning point. Okay, let's do our points of intersection first. So it cuts the y axis when x equals 0, the other number, the other letter. So when x equals 0, we get 0 minus 6, 0 plus 4. So that's minus 6 times 4, which is minus 24. So it cuts the y-axis at 0 minus 24. There's our first thing. It cuts the x-axis when y is 0. So it cuts the x-axis when the other letter y equals 0. So subbing that in, we get x minus 6. X plus 4 equals 0. Well, that's already factorized, so we can now just solve that. That means that x minus 6 equals 0, so x equals 6, and x plus 4 equals 0, so x equals minus 4. So we've got our 2 points, along 6 up 0, and minus 4, 0 as well. Now, the turning point is interesting. There's a couple of ways to do it, but the simplest way is to realise that the turning point happens in the middle of the 2 roots, where it cuts the x-axis. So I want the middle of 6 and minus 4. So for my turning point, all you have to do to get the middle is add up 6 and minus 4, 6 plus minus 4, and then divide by 2. So 6 minus 4 is 2, divided by 2 equals 1. So x equals 1. Is the turning point. I now need the y, but we know y is x minus 6 and x plus 4. So y equals x minus 6, 1 minus 6, and x plus 4, 1 plus 4. 1 minus 6 is minus 5, 1 plus 4 is 5, that equals minus 25. So our point is 1 minus 25. We've now got our turning point where it cuts the x and y axis, so we can just draw a nice quick sketch. X and y. So we've got along 1 down minus 25, which is labelled at 1 minus 25. It cuts the y-axis at minus 24, so let's just say there at minus 24. And it goes through 6 and minus 4. So minus 4 over here, 6 over here, try to make it as symmetrical as I can. And then just a nice curve. Try to make it as neat as you possibly can, but there you are, that's good enough. SQA National 5 Maths 2023, paper 1, question 4. The graph shows part of a parabola in the form y equals x plus a squared plus b. Now we're completing the square. State the value of a and state the value of b. So from the turning point, remember, if it's in completed square form, if I write this out, it would be y equals, so you've got x, and the sign changes for a. So it's 3 here, so it's minus 3. But for b, it stays the same. so it's plus 2. So if I had it like that, our turning point would be 3, 2, which is what it is. So A is minus 3 and B is 2. It now says P is a point 0C. Find the value of P. Well, 0C means it lies on the y-axis, as you can see here. So we're looking for a point of intersection with the y-axis. The easiest way to do it from completed square form is you square this number and then add that number. So we've got minus 3 squared is 9 plus 2, which equals 11. So C. Question 5 says express x squared plus ax plus 15 in the form x plus a squared plus b. This is called completing the square. A half the middle number, immediately take it away. I've still got plus 15 on the end, so I've got x plus 4 squared minus 16 plus 15. So I've got x plus 4 all squared minus 16, add 15 is minus 1. Hence the otherwise state the coordinates of the turning point of the graph. Well, completely square form tells you the turning point, it is 4, but then it's the opposite, so it's minus 4 and then minus 1. So we've got minus 4, minus 1, job done. SQA National 5 Maths 2014 Paper 1 Question 13. The diagram below shows the path of a small rocket which is fired into the air. The height h of the rocket after t seconds is given by 16t minus t squared, which is a quadratic, and you can clearly see a parabola there. After how many seconds will the rocket first be at a height of 60 meters? So for part A, it's telling us that h equals 60. So I just sub that in. I've got 16t minus t squared equals 60. So moving everything over so that it equals 0, I'll move it to the right so I get a positive t squared. So that gives me t squared minus 16t plus 60 equals 0. So all I've done is I've moved the minus t squared over to make positive t squared, and I've moved the 16t over to make minus 16t. I've now got a quadratic to solve, so I look for a common factor. There isn't a common factor, so I'll try and factorise it. Now, if it doesn't factorise, I'll use the quadratic formula. But it is paper 1, so chances are it will factorise. So double brackets, t and t. I'm looking for two numbers at times to make 60, but add to make 16. So I can make a little table with myself, 16 and 60. So 1 and 60, that doesn't work. 2 and 30, that doesn't give me 16. 3 and 20, that doesn't give me 16. 4 and 15, well, that doesn't give me 16. Eventually you'll get to 5 and 12. 5 times 12 is 60, but 5 plus 12 doesn't work either. And then you'll get to 6 and 10. And eventually 6 and 10, 6 tens are 60, plus 6 plus 10 makes 16, but we'll try to make minus 16, so it's minus 6 minus 10. Minus 6 minus 10. Now you might have got there quicker, and if you did, well done. That means that t equals 6 or t equals 10. So at first, how many seconds will it first be at a height of 60? The first one's 6. So our answer is t equals 6 seconds, and we're done there. So we highlight it and underline it. It now says, will the rocket reach a height of 70 meters? Well, the maximum it ever is the maximum turning point, which is here. So we need to work out where the turning point is and then find out whether or not at that turning point what the height is. So we know we've got 6 and 10. So for part B, our turning point happens at 10 plus 6 divided by 2. You add the roots and you half it to get the middle of them. 10 plus 6 is 8, divided 10 plus 6 is 16, divided by 2 is 8. So the turning point happens at 8 seconds. So when t equals 8, we have got h of t is 16t minus t squared. So when t equals 8, we've got that equals 16 times 8 minus 8 squared. That's 128 minus 64, which equals 64 meters. So then we just write a little statement. Max height equals 64. So rocket never reaches 70 meters. And we're done there. SQA National 5 Maths 2019 Paper 2 Question 6. Solve the equation 3x squared plus 9x minus 2 equals 0 to 1 decimal place. Right, it's a quadratic. It's asking me to 1 decimal place, so it's a quadratic formula. So I go to the front of the page and write down the quadratic formula. Minus b plus or minus the square root of b squared minus 4ac all over 2a. Now in this case, a is the number in front of x squared, which is 3. B is the number in front of x, which is 9. And c is minus 2. So I need to sub this in carefully. That's minus 9 plus or minus the square root of 9 squared minus 4 times 3 times minus 2 all over 2 times a, 2 times 3. So you get a mark for substitution usually, then a mark for working out the bit under the square root sign, which is called a discriminant. So I'll work it out next. Minus 9 plus or minus the square root of, well, 9 squared is 81. Well, let's use a calculator, shall we? So we've got 9 squared minus, I'll open a bracket, 4 times 3 times minus 2. That's 105. All over 2 times 3, which is 6. So now we've got two answers, x equals minus 9 plus root 105 over 6, or x equals minus 9 minus root 105 over 6. So let's do them both separately with a calculator. Brackets for the top, minus 9 plus root 105. Close the bracket, divide it by 6. That gives me 0.207a. I'll just put dot, 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 and then the other one, brackets, minus 9 minus root 105 over 6 is minus 3.207 with a bunch of other numbers. And we'll round that to 1 decimal place, so then that gives me 0.2 or minus 3.2. Always show your unrounded answers first before you round. SQA National Maths 2025, Paper 1, Question 15. The diagrams of a rectangle and square are shown, all measurements in centimetres. Find an expression for the area of the rectangle. Well, area is length times breadth, so I've got L and B. So that's just 2x plus 3 and x plus 1, and it's only worth 1 mark, so I don't think I need to expand it or anything. So we're done there. Given the area of a rectangle equals the area of a square, show this. So this is your standard thing. There's my area of a rectangle again. And that equals the area of the, and it says it's a square, so that's x plus 3. So that's x plus 3 times x plus 3. Or x plus 3 all squared. So expanding the brackets any way you want, I'll use my grids. 2x plus 3, x plus 1 equals x plus 3, x plus 3, 2x squared plus 3x plus 2x plus 3, x squared plus 3x plus 3x plus 9. So that gives me 2x squared, 3 plus 2 is 5x, and then plus 3 on the left, and then x squared, 3x plus 3x is 6x, and then plus 9. So moving everything over, 2x squared minus x squared is just x squared on this side, 5x, then take away 6x is minus x, and then 3 take away 9 is minus 6 equals 0, and that's what we want to show. But remember, if you can't do this question, you can still do part C, because you're just solving it. So part C says, hence find algebraic with the length and breadth of the rectangle. So we've got x squared minus x minus 6 equals 0. A quadratic equation, and since we're in paper 1, it probably factorises. Double brackets, x and x, 2 numbers at times to make 6, but add to make 1, well that's 3 and 2. And I want minus x, so minus 3 plus 2 is minus 1. So that says that x plus 2 equals 0, and x minus 3 equals 0. So x equals minus 2, and x equals 3. But we can't have that because you have to have, can't have negative lengths. So we're going to use 3. So then we need to actually work it out. So way back up here, we've got length is 2x plus 3 and breadth is x plus 1. So our length was 2x plus 3 and our breadth was x plus 1. So we're using x equal 3. 2 times 3 plus 3. 6 plus 3, 9 centimetres. This one, 3 plus 1, 4 centimetres. And we're done there. SQA National 5 Maths 2025, Paper 1, Question 11. Determine the nature of the roots of 3x squared plus 2x plus 1. So I'm looking at b squared minus 4ac for this. So a is 3, b is 2, c is 1. So I've got 2 squared minus 4 times 3 times 1. That's 4 minus 12, which is minus 8. So since b squared minus 4ac is less than 0, there are no, you need to use the word real, roots. And we're done there. SQA National 5 Maths 2019, Paper 1, Question 4 had this arc length question. It says the radius is 30, the angle is 240, calculate the length of the major arc. Now this is Paper 1, so it's non-calculator, so I'm going to give you some hints for this one. You still start off in the same way, don't be worried. Arc length equals angle out of 360 times pi times diameter. Now we can just substitute in. Our angle is 240 out of 360 times by pi times by 60. Double 30 makes 60. So now at this point, you might be wondering, what can I do? Well, to calculate this with a non-calculator, always best to simplify any fractions first. So I'm just going to take it beside 240 over 360. I can drop the zeros to straight away to get 24 over 36. And then I'm looking for two numbers at times together to make 24. A number that goes into 24 and 36. Well, 4 goes in, I know that straight away, so I'll divide by 4. 4 sixes is 24, 4 nines is 36. Oh, I can see 3 goes in as well. And you could have got there quicker by dividing by 12. 3 twos is 6, and 3 threes is 9. So our sum now can be replaced with this fraction. I've got arc length is 2/3 times pi times 60. I'll leave the pi to the end. So I've now got 2/3 of 60. So I divide by 3 and times by 2. 3 20s is 60. 20 times 2 is 40. So I've got 40 times pi. So that's 40 times 3.14. So we need to do this sum. So there's lots of ways to do it, but times them by 40 is the same as times them by 10 and times them by 4. So again, at the side, you can just do 3.14 times 4. 4 fours is 16, carry 1. 4 ones is 4, plus 1 is 5. 4 threes is 12. So you get 12.56. So that is 10 times 12.56, which is 125.6. And our units were centimetres. SQA National 5 Maths 2019, Paper 2, Question 13 on sector area and similarity. It says in the diagram, the sector ABC is a sector of a circle with a centre C, and DEF is a sector of a circle with a centre F. The sectors are mathematically similar. It says the area of the larger sector is 2750. Find the area of the small sector. So we're using area scale factor. So we need to find the linear scale factor first and then find the area scale factor. So we have to do the smaller one. So we start with the smaller side, 30 over the big side, 50. So our linear scale factor is 30 over 50. Or you can simplify that to 3/5 if you want, which means our area scale factor, remember, we'll just square that scale factor. 3/5 squared. Calculator paper, so you can just do 3 threes is 9, 5 fives is 25 in the calculator. So now to get the area of the smaller sector, we just take our scale factor and times by the area of the big sector, which is 2750. Now this is a calculator paper, so let's just do that. 9 divided by 25 times 2750 is 990. 990 centimetres squared, and we're done there. He says calculate the size of angle ACB. So we're in the big sector, and we know that if we've got an angle, then angle over 360 times pi r squared, because we're doing sector area, equals the area. Well, the area I'm given is 2750 for the big sector. So we're just working backwards from there. So to get your theta, I find the easiest way to work backwards is start with your answer, which is 2750. And as you go back, every time something's on the bottom, that now turns up on the top. So times 360. And anything that was originally on the top for times in, we just divide by it. So we've times by pi r squared. So we divide by pi r squared. And R, remember, for the big sector is 50. Pi times 50 squared. And then we just get a calculator and work all that out. Now you can do it in one go in the calculator. You just bracket 2750 times 360 divided by bracket pi times 50 squared. Close your bracket and you get 126.05 or 126.1 degrees. And we're done there. Maths 2024, paper 2, question 7. A paperweight is in the shape of a cuboid. It consists of a hemisphere of lead glass surrounded by clear glass. The cuboid is 4 centimetres with a square base of 7 by 7. And the hemisphere has a diameter of 6. Calculate the volume of the clear glass in the paperweight. So obviously the hemisphere takes up some space. So I need to do the whole volume minus the hemisphere. So I've got the volume of a cuboid. So the volume is going to be 7 times 7 times 4. Hopefully you can all do that. Minus the volume of a hemisphere. Well, check the start of the exam paper and you'll get 4/3 pi times r cubed. Now, let me just write that up here. That is a sphere. So the radius is equal to 3 because it's half of 6. So 4/3 times pi times 3 cubed. But I need to do a half of that or divide by 2. So times a half or divide by 2 because it's a hemisphere. Now, most people work these out separately. So 7 times 7 times 4 is 196 minus 4 divided by 3 times the pi button times 3 to the power of 3 is 113.097. Divide that by 2 or times it by a half is 56 point. Now, I wanted to do significant figures, so just a reasonable number here, 54866, blah, 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 and if above it to round until at the end, 196 minus 56.54866. Now, it would have been 67 actually, but I've put dot, 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 so I'm safe there. So that gives me 139.451 and a bunch of other numbers, and I only need 2 significant figures, so I'm rounding here. That rounds up to 140, and the units are centimetres cubed. And there you are, there's your volume of the paperweight glass. Pythagoras and Circles, SQA National 5 Maths 2018, paper 2, question 13. We have got this shape and we know the radius is 13, this length is 20, calculate the width. So if I knew here to here is 13, so I need this little bit here. So I can add that in, call that x. Make a radius, that's 13. Right angle triangle then, so that is 10. So we know that x squared equals 13 squared minus 10 squared. So x is the square root of 13 squared minus 10 squared, which equals 8.3. Not rounded. So then the width is just our radius 13 plus our 8.3 that we've just worked out to give us a final answer of 21.3 centimetres. And we're done there. SQA National 5 Maths 2019, paper 2, question 18 had this question. It's a cartoon snowman and it's got a lot of information about the head is a small circle with centre S and the diameter of that from here to here or here to here is 15. The large circle has got a centre of T and it also lies on the circumference of this one, and A and B lie on the circumference of both circles. Calculate the height of the snowman. Looks quite difficult, but if we notice, we know this line here is 15, so we're really just being asked to calculate the radius of the big circle. Now we can calculate it anywhere. So if I go inside this bit from here to the outside, that's a radius of the big circle too. I'll draw that in. And we already know of some facts. We know that'll make a right angle. but we know that the diameter of the small circle is 15, so that is 7.5, but so is this. So taking that outside of the circle, just to be clear, we have got 7.5 here and 7.5 here with a little x here. So x squared is 7.5 squared plus 7.5 squared. So that means that x equals the square root of 7.5 squared plus 7.5 squared, which we can calculate and then square root or just use brackets to get about 10.6. So that means now that our height is just, well, let's just double check. It's going to be the diameter to t, which is 15, plus the radius of the big circle, which we've just worked out is 10.6. That gives you 25.6 centimetres. 2019, paper 2, question 11. Converse of Pythagoras. The diagram shows a jet ski race. The course is marked out by markers A, B and C. It says B is 600 metres from A, C is 650 metres from A, and C is due north of B. Determine whether B is due east of A. Well, if it is, it will be a right angle. Now, you cannot use Pythagoras to get this missing side because you're going to try and prove it's a right angle. So we'll start off with the fact that the whole course is 1500. 600 plus 650 is 1250. We take that away from 1500 to get 250 metres, and we just mark that on. We know that's definitely 250. Keeping it all separate, we've got a left-hand side and a right-hand side. Our left-hand side is 600 squared plus 250 squared, and our right-hand side is 650 squared. Do not write they're equal, that's why I draw a little table and keep them separate. We then work out both sides separately. So the first sums gives us 422,500, and 650 squared, if you work that out in a calculator, also gives you 422,500. So then you can say, since 600 squared plus 250 squared equals 650 squared, then angle is right angled is a right angle. So we could then write what we're trying to say. A is east of B. B is east of A, sorry. And we're done. The SQA National 5 Maths 2022 Paper 2 Question 11, another 3D Pythagoras question, and it's telling us that the length of the cuboid is 24, the breadth is 6, so there's my length and breadth, and the height is 8. Calculate the space diagonal from front to back. So it's just 3D Pythagoras, 24 squared plus 6 squared, the base, times the height, 8 squared. So I can write 24 squared plus 6 squared plus 8 squared all in one go. And then we can work out that by doing it's the square root of all of that. So we can do the square root all in one go, just put brackets around the sum, and you will get 26 centimetres. National 5 Maths 2025, Paper 2, Question 7. In the diagram, ABCDE is a regular pentagon. EFA is 65, we have to calculate FAB. FAB is a straight line, sorry, calculate FEA. FEA, so we're trying to get to here. So, first of all, pentagon. So I can do 360 divided by 5 to get the angle in the centre. That is 72 degrees, just use your calculator. So we've got 72 in each of the centres, but I'll just put one of them. And this will be an isosceles triangle. So I can do 180 minus 72. 180 minus 72 is 108. 108 divided by 2 then is 54. So we can get 54 degrees at the extremities. Don't need the other one, but put it in if you want. And we also know that this one's 54 then because of symmetry. 2 54s is 108, so I can now do 180 minus 108 to get this one here, because angles on a straight line add up to 180. That gives me 72 up here. And then finally, our angle FEA, well, angles in a triangle are up to 180, so 180 minus 65 minus 72. 180 minus 65 minus 72 is 43 degrees. And we're done there. SQA National 5 Maths 2024, Paper 1, Question 10. The diagram below shows a circle centre O. AC is the tangent to the circle at B. There it's there. And CE is the tangent at D. There it's there. And BG and DF are diameters. Angle DEFE is 125. Find the shaded angle, which is way down at the bottom. So let's start off with our rules. Tangent meets a radius at right angles. We've got angles on a straight line. And then the main other one is two radiuses make a isosceles triangle. So if we can get into here, then we can maybe get this angle, which means we can maybe get that angle. And then we need to work at these somehow and then get that angle. So let's just start from there. So I'm going to do 180 minus 125. So 25, 35, 45, 55, 65, 75 makes 55. So I now know that this one up here is 55. But because that's a radius and that's a radius, this one down here is also 55. So I can now do two 55s as 110. 180 minus 110 is 70. So I get 70 in the middle straight away, basically. And a little rule you should know is if two lines cross, vertically opposite angles are equal. So the ones that are opposite each other are equal. So that gives me 70 here. And angles round a point add up to 360. So I've got 140 already. So if I do 360 minus 140, that will give me what's left between these two. And they're the same size that you can see. We'll check that in a minute, but I'm pretty sure they are. So that is 0, that is 2, and that is 2. So divide by 2, I get 110 here and 110 there. Let's just double check they are the same, and we can do that by doing this. Next rule, tangent meets a radius at right angles. So let's point all right angles in. There's 1, there's 1. This will be a right angle there, and we've got 1 here. And since that is a right angle, then this triangle here gives me 20 up there. Now, if that's 20 up there, then that means that we're good to go. So let's look at a big triangle. You probably don't have to do this in the exam, by the way. It's just to double check for this. 70, 90, 20. Yeah, so I've got all the angles. But you can go straight ahead from your 110, and now you know that this is 90 here and 90 here. I have got a four-sided shape. And four-sided shapes, the angles add up to 360. So I've already got 90 and 90 is 180. So that means that these two opposite add up to 180. So I get my 70 down here, and I'm done there. Now, big note on this one. If you just get 70 here and let your answer is 70 without any more working, you won't get the answer because you have to show where that 70 comes from. Okay, although there's 70, you have to show where that 70 comes from. And that's that done. SQA National 5 Maths 2025, Paper 2, Question 11. Two models are mathematically similar. The small model has 14 centimetres long, and the area of one of the wings is 24 centimetres squared. I'll just write that. Area equals 24 centimetres squared of something. The large model is 31.5 long. What is the area of the wing of the large model? Well, this is a scale factor. So the linear scale factor, I want to find it in the big one. So I do the big side divided by the small side. Now, I don't need to work this out, so I'm just going to leave it like that. But that means that the area scale factor is 31.5 over 14 all squared. So to get my new area, I take my area scale factor and times by my small area. So the area is equal to 31.5 over 14 all squared times 24. And that's just a calculator job. Brackets, 31.5 divided by 14, bracket, squared, just press equals I think, times 24, 121.5 centimetres squared, and we're done there. SQA National Maths 2024, Paper 1, Question 14. In the diagram, triangles ABC and ADE are similar. So they're similar, so I've got ABC, let's just do that, and that is 3 centimetres here. And then it says ADE, the big one, ADE. Well, we've got 10.5 here. And then we've got 7 on the bottom. So hopefully you can see that since they're similar and this side is this side, I can do the scale factor and I can then find the length here. So I'm just going to go ahead and do that. So the scale factor is equal to 3 over 7. So that means this length here, x, is 3/7 of 10.5. So that is equal to 3 tens are 30. Well, 3 5s is 15, carry 1. 3 tens are 30 plus 1 is 31.5 over 7. 31.5 divided by 7. Well, 7 4s is 28. 29, 30, 31. 7 5s is 35. So that gives me 4.5. So I now know that this bit here is 4.5. And it asks me to calculate BD, which is this bit here. So that means I need to do 10.5 minus 4.5. So BD 10.5 minus 4.5. 4.5, 5, 6, 7, 8, 9, 10.5 is 6. And the units are centimetres. SQA National 5 Maths 2025, Paper 2, Question 15. In the diagram below, DG and GE are R and S, and they're shown in the diagram. But it also says that DE is 3EF. So in other words, here to here is 3 of here to here. I have to go from G to F. I need to go there. Now I can't go that direction. So I could go up here, but then I'll need to know that one. Or I could do some funky thing like go up here and go all the way along, but I still need to know that one. So I'm going to have to work out D to E in some way, or E to F. So let me do D to E. To work out D to E, I could do a journey of starting at D. I could go down R. And then I could go up S. So we know that that's R plus S. So D to E is R plus S. And we know that E to F is a third of that because D to E is 3 of E to F. So E to F is a third of D to E. And now I can find my G to F. G to F is just going to be starting at G. I need to get to F, so I can go up S plus along here, which is E to F, a third R plus S. Expand the bracket, S plus a third R plus a third S. S plus a third S is 4/3 S, say, plus a third R. And we're done there. SQA National 5 Maths 2024, Paper 1, Question 4. A is 3, 4 minus 1, B is 5, 3, 2. Find 3A plus B. Okay, so 3A plus B. So I need to times A by 3. 3 3s is 9. 3 4s is 12. 3 1s is 3, so it's minus 3. Plus B, which is 5, 3, 2. So being careful, 9 plus 5 is 14. 12 plus 3 is 15. And minus 3 plus 2 is minus 1. And we're done there. SQA National 5 Maths 2019, Paper 2, Question 2. Find the magnitude of vector P. So magnitude is just like Pythagoras. I just square each number and square root them. 6 squared plus 27 squared plus minus 18 squared. Square root 6 squared plus 27 squared plus minus 18 squared is 33. And we're done there. National 5 Maths 2019, Paper 2, Question 5. The diagram shows a cone with diameter 6 and 8. The x and y axis are tangents to the base. A is the point of contact with the base on the x-axis, and B is directly above the centre. Find A and B. So let's see where A is. We need to go from here to here. Well, that length is the diameter 6, so that length is 3. I can just take a note of that here. That goes along 3. I go along 3. I don't go in and I don't go up. So it's 3, 0, 0. So straight away, A equals 3, 0, 0. Let's find B. B, I need to go along 3, in 3, because again, diameter 6, and then I need to climb up the whole height. Now the height is 8, so it's 3, 3, 8. And I'm done there. SQA National 5 Maths 2025, Paper 1, Question 5. Triangle ABC is shown, AB and BC are 6. Sine B is 2/3, find the area. So start with exam paper, area is a half, AB sine C. Doesn't matter about this, all that matters is that angle in between is the one you're looking at, two sides. So angle in between I've got, and two sides. So the area is a half times 6 times 6. And it tells you the sine of the angle, so I just write 2/3, because it's non-calculator. A half of 6 is 3. And then I can do 2/3 of 6. 6 divided by 3 is 2, times 2 is 4. So I get 3 times 4, which is 12 centimetres squared for the area. And we're done there. 24, paper 2, question 13. AC is 22, BAC is 40, then we've got 30, and then BD is perpendicular to AC, find the length of BD. So I've got triangles, so it's probably something to do with sine or cosine rule, and I need to find a length. Now, I can't really do much if I've got no lengths in this triangle and no lengths in this triangle. So I'm going to have to find a length. So I'm going to have to use a rule. So let's see if we can find out any angles first. 40 and 30 is 140 and 30 is 70. So that whole angle in here is 110. And now I've got opposites. So I can do that and that go together, and then any angle I want, either this one or this one, and the opposite side. And then I'll have a side, and once I've got that, I can just use SOHCAHTOA, or the sine rule again, double sine rule a lot of people use. I'll probably use SOHCAHTOA for speed. So we have got, start exam paper, A over sine A is B over sine B, is C over sine C. That's just to remind you, but it's just that I think about opposites. So I've got the whole length 22 over sine 110 equals, and I'm just going to find this one. So that is, I'll call it A because it's opposite A, equals A over opposite sine 40. So we can rearrange that. A sine 110 equals 22 sine 40. So A is 22 sine 40 over sine 110. So getting a calculator. 22 sine 40 divided by sine 110 is 15.048. So 15.05 would be reasonable in centimetres. So now we know that this is 15.05. So you could either use the sine rule again in the right angle triangle or just SOHCAHTOA. Let me just draw that out. I've got this triangle here, and I've got 30 degrees down here, and I've got 15.05 here. And I'm trying to find the height, which I'll just call x. So you could just say I've got opposite over hypotenuse, which is sine. So sine 30 equals x over 15.05, or x equals sine 30 times 15.05. 15.05 times sine 30 is 7.525, or 7.5 centimetres. Or if you wanted to use the sine rule again, then you could say you've got, if I just do this at the side, x over sine 30 equals 15.05 over sine 90. And if you rearrange that, you get x sine 90 equals 15.05 sine 30, which means that x is 15.05 sine 30 over sine 90. But because sine 90 is 1, and if you use your calculator, you'll get that. You'll get the same answer of 7.5. And we're done there. SQA National 5 Maths 2023, Paper 2, Question 4. The diagram shows triangle JKL. It tells you angle KJL is 25. JL's 10, KL's 7, calculate the size of angle JKL. So JKL is up here, so it's this angle it wants. So it looks like this is a sine rule because you've got opposite, 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 opposite. So I can say, just remember from the start of the exam paper, A over sine A is B over sine B is C over sine C. So the information I've got is 7 over sine 25 equals opposites 10 over sine K. So we can do 7 times sine K is 10 times sine 25. So that means it's sine K is 10 sine 25 over 7. So let's work that one out. 0.6037 4. So K is the inverse sine of my answer. Which is equal to 37.1 degrees. Or you'd probably find with just 37 because every number's to two significant figures in the question. SQA National 5 Maths 2023 Paper 1 Question 6. AC is 5 metres, BC is 6 metres, cos C is a fifth. Calculate the length of AB. So this is one of those questions where we're using the cosine rule, but we're giving you the cos of the angle so you can just go straight away. So let's remind ourselves of the cosine rule. Let's start with the exam paper. The cosine rule is a squared equals b squared plus c squared minus 2bc cos of a. Now that's just a generic a, b and c, remember, so you can either relabel your sides to get your a, b and c where you want it, or just remember that the side A is the one opposite the angle you're given, which is cos C. So I'm going to do it that way. I'll just call that my A, and I'll just call that my B and C, and therefore that's my little a there. So I can say that my A squared equals 5 squared plus 6 squared minus 2 times 5 times 6 times the cos of A, which is cos of C, because that was originally C, remember, so that's a fifth. And now we can start working on that. A squared equals 25 plus 6 sixes is 36. 2 fives is 10. 10 sixes is 60. A fifth of 60 is 12, so minus 12. So A squared is 36, 46, 56, 61, minus 12 is 59, 49. And therefore A is the square root of 49, which is just 7 meters. And then just to answer the question then, it says calculate the length of AB. Length of AB equals 7 meters. And that's just to be on the safe side because I've relabeled the sides, but you'll probably find if you didn't do that. 24, paper 2, question 3. AB, AC, and BC is in a triangle, 25, 18, 34. Find the size of a shaded angle. So I've got 3 sides of a triangle. So I say 3 sides means the cosine rule. So you go back to the start of the exam paper and copy the cosine rule for an angle, which is cos A equals b squared plus c squared minus a squared over 2bc. Cos A equals b squared plus c squared minus a squared over 2bc. SQA have been quite happy here that we're giving you A and that's A, so that's B and C. But I don't really care about the letters usually. In between is your B and C and the angle's in between. So it's 18 squared plus 25 squared minus 34 squared over 2 times 18 times 25. Usually work at my top and bottom separately. 18 squared plus 25 squared minus 34 squared is minus 207 all over 2 times 18 times 25, which is 900. So that's cos A. So I do the inverse cos. I usually just keep it as positive and use a cast diagram. But we'll see what happens if you did it negative. You'll probably be okay. But I'm going to always do it that way because it's the right way to do it. Inverse cos 207 over 900 is 76.7 degrees. So now I need to find my angle by using a cast. Cos is negative, so it's not A and C, it's S and T. So that means that my answer for A is 180 minus 76.7. Which is 103.3. So we get 103.3 degrees, and we're done there. Now, let's just check what would happen if you'd done shift cos and done minus 207 over 900. Happily, we give you it as 103.3, so you're done there. Now, I never do that. I always use the cast diagram when cos is negative, so I'm consistent with all my working. But there we are. In National 5 Maths 2025, Paper 2, Question 12. In the diagram, A, B and C represent positions of 3 checkpoints on an orienteering course. B is 250 east of A, C is on a bearing of 131, it's shown in the diagram anyway, and C is 200 meters from B. Calculate the bearing of C from B. So from B, I need to calculate going round that way to get back to C. Don't worry if you couldn't do the whole thing, but let's just start it from where we can start it. 90-degree angle there. There must be one there as well then, so I can do 131 minus 90. That's 41 degrees, and that gets me 41 inside the triangle. So now, is there any other angles I can work out? Well, not quite, but I can do the sine rule because I could do this pair go together, and I can't find anything with this and this, but I could find this angle here using the sine rule. Now, if I knew that angle, then angles in a triangle to 180, so I could get this angle, which means I'll get the other side. So that's going to be my approach, using the sine rule. So let me just mark the angle I'm focusing on. I'm marking this one. I'll just call that X. So we have got 250 goes with that one. 250 over sine X equals 200 goes with this one. 200 over sine 41. So we rearrange that. That times that. 250 sine 41 equals that times that. 200 sine X. And we write that again. 250 sine 41 equals 200 sine X. Divide by the number in front of sine. So sine X is 250 sine 41 over 200. 250 sine 41 divided by 200 is 55.092, or about 55.1 degrees. So we know that's 55.1, so we can work out the other angle just by doing 180 minus 55.1 minus the 41 we already know to get 83.9. So our bearing, remember, was going all the way around here. Well, we now know that on the left-hand side of that, we've got 90 plus 83.9. Which is 173.9. So our bearing then is just going to be all the way around the circle is 360. We already know that bit, so we can just take away for 360. So our final answer is 360 minus 173.9. Which is 186.1 degrees. Or bearings are usually 3 figures, so about 186 degrees, but you'll probably be fine with 186.1 or whatever rounding you want. SQA National 5 Maths 2025, Paper 1, Question 8. Part of the graph of y equals 2 sine x minus 30 is shown. The graph has a maximum turning point at A. What's the coordinates? So thinking about this, a normal sine graph looks like that, and it goes to 1 and minus 1, and it cuts here at 90. So if I think, well, what's happened to that graph? Minus 30 means it shifts to the right by 30. So I need to add 30 onto 90 to get 120 degrees. And then it's 2, so its max must be 2, and the min must be minus 2, so the second number is 2, 122, and we're done there. SQA National 5 Maths 2023, Paper 1, Question 13. Part of the graph of cos x plus a degrees plus b is shown. State the value of a, state the value of b. So our standard cos graph, remember, just to remind you, goes like this, and it's between 1 and minus 1, 90, 180, 270, and then right at the end, 360. Not a great picture there, but you get the idea. So, the amplitude is between 1 and minus 1. So, the amplitude stayed the same, but it's added a number. It's went from 1, and its maximum value is now 2. So, b is simply 1. And for state the value of a, it's a shift to the right or the left. So, looking at this turning point here, we can see that the turning point usually happens at 180, but it's shifted by this amount. Well, what's that amount? Well, it's going up 1, 2, 3, so it's going up in 30, 90, 30, 60, 90, so 180, 210. It's shifted to the right by 30 degrees. A shift to the right means a negative number, so a equals minus 30 degrees, and b is equal to just 1. So that's the graph of cos of x minus 30 plus 1. SQA National 5 Maths 2022, Paper 2, Question 9 had 3 sine x plus 4 equals 6. So taking away 4 for both sides, we get 3 sine x degrees equals 2. And therefore sine x degrees equals 2/3. So then we can find the inverse sine. You've got a mark already. So the inverse sine of 2/3, you do the inverse sine of 2 divided by 3 in a calculator, and you get 41.8 degrees. And then you need to find your second value using your cast diagram. So sine was positive, so it's a and s. So I need to do 180 minus 41.8 degrees, and that gives us 138.2 for our second mark there. And one SQA National 5 Maths 2025, Paper 2, Question 14. The ride at a theme park car has attached to the end of a rotating arm. The starting position of the car is shown in the diagram. As the arm rotates clockwise, height meters above the ground. Each rotation is given by, there's our key thing, h equals 10 minus 8 cos x. Trig equation, where x is the angle. Calculate the two values of x for which the height is 13 meters above the ground. 13 meters, so I'll just write 10 minus 8 cos x equals 13, and I need to solve that. So I move the 10 first, this is your first sticking point, so the minus 8 cos x is staying where it is. Opposite of 10, which is opposed to the numbers minus, so that gives me 3. And I need to divide by minus 8. So I get minus 3 over 8, or 3 over minus 8, but I prefer minus 3 over 8. So now you do the inverse cos, and this is your sticking point. Don't do the inverse cos of a minus, because you get a wrong answer, because you're trying to do the cast diagram, it only works for positive numbers. So do 3/8 only. Shift cos 3 over 8 is 67.975, blah, 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 or about 68 degrees then. Cast diagram. So our cos was negative. So usually I pick A and C, but I picked the opposite. So it's S and T. So at S we do 180 minus the angle, 180 minus 68. And at T we do 180 plus the angle, 180 plus 68. Two answers. 112 degrees, 248 degrees, And we're done there. SQA National 5 Maths 2024, Paper 2, Question 16. Express 3 cos squared x minus 1 in the form a plus b sine squared x. What the hell? That looks tricky, doesn't it? I bet you everybody thought that one was tricky. There's 2 you need to know at National 5. Sine divided by cos is tan. Well, we've got a square, so that... Or sine squared plus cos squared equals 1. So we're going to use that. If I've got sine squared x plus cos squared x equals 1, and my answer, a plus b sine squared x, doesn't have a cos squared x in it. But I'm going to have to get rid of this cos squared x. So I'm going to have to rearrange this to work out what cos squared x is. Well, cos squared x is equal to, take away sine squared x, 1 minus sine squared x. So I can now just sub that in. So 3 cos squared x minus 1 equals 3 1 minus sine squared x, with minus 1 sitting on the end. That's 3 times 1 is 3, minus 3 sine squared x, minus a 1. 3 minus 1 is 2, 2 minus 3 sine squared x. And we're done there. SQA National 5 Maths 2022, Paper 2, Question 13. Another trigonometric identity question. Simplify sine x plus 2 cos x over cos x. Okay, so we could split this up into 2 separate fractions. We've got sine x degrees over cos x degrees plus 2 cos x degrees over cos x degrees. And then we can deal with each fraction individually. You get a mark just for separating them out, by the way. Sine x divided by cos x we know equals tan x. Cos x divided by cos x, well, that just simplifies to 1, that we cancel, so I've got plus 2 left over for our final answer. SQA National 5 Maths 2023, Paper 1, Question 9. The magazine company conducted a survey of the ages of its readers. A sample of the 10 readers is shown. Calculate the median and interquartile range. Oh, that's interesting. So now we need to put them in order to get the median and the interquartile range. So being very careful here. So in order, I've got 31. And then I've got 33, 35, 36, 38, 41, 41 again, 42, 47, and 55. So the median's the 1 in the middle, but there's 10 numbers. So I'm going to have 1, 2, 3, 4, 1, 2, 3, 4, will be 2 in the middle. So it's in between 38 and 41. That would be 39.5. Now there's 2 ways to work it out. Add them together and divide by 2, or realise it was 3 in between them, so 3 divided by 2 is 1.5, so just add 1.5 on. Now to get your quartiles, I want the middle of the left, so there's 1, 2, 3, 4, 5, so it's a 1 here, which is 35. That's quartile 1. And the middle of the right, there's 5 again, so it's the middle of those 5, so that's quartile 3. So we can say our median is 39.5 years, and our interquartile range is Q3 minus Q1. 42 minus 35 is 7 years. Okay, part B is going to be a statement question. It's going to say to us, the newspaper company conducted a survey of the age of its readers. The median was 41 and interquartile range was 9. Make 2 valid comments. So if you're comparing the median, it's just the same as comparing the mean. It's on average is your key words. And if you're comparing the interquartile range, that's the same as standard deviation. It's about variation in the age. So comparing the median first. On average is my key word. I always need that. And then just looking at the newspaper against the magazine. The newspaper was 41. The magazine was 39. The age of newspaper readers is higher. And we can say since 41 is bigger than 39.5. Now to compare an interquartile range, we'll just talk about variability. So I got 7 for the magazine, and for the newspaper it's 9. So the age of the readers of magazines is less varied than newspapers. and the varied is the key word. The age of magazine readers is less varied than the age of newspaper readers, since 7 is less than 9. And we're done there. SQA National 5 Maths 2025, Paper 2, Question 4. The weight in kilograms of a survey of rugby players in Scotland are shown, mean and standard deviation. Start of the exam paper tells you, I use this formula. The standard deviation is the square root of the sum of x minus x bar squared over n minus 1. Now you can use the other formula if you want, but that's the one I use. So I just write x minus x bar squared, 93, 103, 99, 105, 88, 106, and 92. So the x bar is the mean, so I add all my numbers up in a calculator as usual. 93 plus 103 plus 99 plus 105 plus 88 plus 106 plus 92, and divide by how many numbers there are. 1, 2, 3, 4, 5, 6, 7. 98. So I'll take away 98 from each of the numbers in the middle. So 93 minus 98 is minus 5. 103 minus 98 is 5. 99 minus 98 is 1. 105 minus 98 is, well, that's 7. 88 minus 98 is minus 10. 106 minus 98 is 8. And 92 minus 98 is minus 6. You then square each of the numbers you've got. So that's 5 squared is 25, and 25 again. 1 squared is 1, 49, 100, 8 eighths is 64, 6 sixes is 36. Add them all up. 25 plus 25 plus 1 plus 49 plus 100 plus 64 plus 36 is 300 exactly, I get. So our standard deviation is the square root of 300 over 1 less than the number of numbers you had, which is 6. So that gives you the square root of 300 over 6, 7.07. So just to be clear, our mean is 98 kilograms, and our standard deviation is 7.07 kilograms. Just check that. Yeah, 7.07 is fine with me. Part B says, a sample of rugby players in France, and the first one was about Scotland, have a mean weight of 105 and a standard deviation of 5.9. Make 2 valid comments comparing the weights in Scotland and France. So we've got from Scotland, it's 98 and a standard deviation of 7.07 kilograms. And for France, our mean is 105 and the standard deviation is 5.9 kilograms. So we can then just say that comparing the means, on average, the weight of rugby players in, and let's just pick the biggest one, France, is more than Scotland. Is bigger, more, whatever, as long as you mention the weight. And I'll just write since 105 is bigger than 98, just to be on the safe side. And then comparing the standard deviation, that's statement 1. Statement 2, the weight of rugby players is, well, more consistent for a smaller number. So 5.9 in France, more consistent in France. Again, Scotland, I'll just be very, very clear. Since 5.9 is less than 7.07. Now, SQA used to need you to compare the numbers, and in recent years have not needed to compare the numbers, so I'm just put it in just in case. But I wouldn't worry too much if you forgot to put the numbers in the comparing, as long as the statements are correct. National 5 Maths 2023, Paper 1, Question 7. A business records the sales of a sample of its employees in the length of time they worked for the business. The scatter graph shows the relationship between their salary and the time and years they worked. The line of best fit is shown, so it's a straight line question. Find the equation of a line of best fit in terms of P and T. Give the equation its simplest form. So to find the equation of a line, you need to find the gradient, and then you need to use the formula y equals mx plus c, or y minus b equals mx minus a. So I need the points for gradient, so let's pick some points. There's one clearly there. That is 5 to 1,000. 20,000, sorry. And the second point we can pick is clearly identified here, which is 25, 50,000. So starting off with our gradient, y2 minus y1, x2 minus x1, that's x1, y1, that's x2, y2. So that gives me 50,000 minus 20,000 divided by 25 minus 5. So that's 30,000 on the top divided by 20 on the bottom. Quite a big number to deal with, but we can get rid of the zeros to start with. And that gives me 3,000 divided by 2, which is 1,500 or 1,500. So there's our gradient. So now we can do y minus b equals mx minus a is how I usually do it, or y equals mx plus c if you prefer. So there's our straight line, and I'm going to use the point A and B, positive numbers, so nice and straightforward. Y minus 20,000 equals 1,500 times x minus 5. Don't be worried about the big numbers because it ends in zeros, so we can deal with that. So that's y minus 20,000 equals 1,500x. And we need to do 5 times 1,500. So 5 15s is 75. So minus 7,500. Adding 20,000 to both sides, we get 1,500x. 20,000 minus 7,500 is 12,500. So there we go in terms of y and x. But our graph is in terms of P and T, P and time. So we need to change the y-axis to P equals 1,500t plus 12500. Just make sure it's a capital T. It is. So we're done there. Part B, use your equation from Part A to estimate the salary of an employee who has worked for the business for 8 years. So remember, our P was 1,500t plus 12,500. And they're saying that 8 years, so that means that the pay is 1,500, time is 8, plus 12,500. Okay, 8 times 1,500, so if I double it, I get 3,000, double again 6, double again 12, so I get 12,000 plus 12,500, which is equal to, with a pound sign, £24,500. Let's see if that agrees with the graph. That looks about right, so we're done.